Toledo, Ohio, 1938. An engineer named Barney Roos straps a 4-cylinder engine to a dynamometer. The engine has been in production since 1926. It makes 48 horsepower. Roos sets the throttle to wide open and walks away. 22 hours later, the engine dies. This is not acceptable. Roos has set his own benchmark, 100 hours at full power. Not gentle cruising, maximum sustained abuse. The engine failed at 22% of his standard. 3 years later, a derivative of that same engine block will power 640,000 vehicles across every theater of the Second World War. Eisenhower will cite the Jeep as one of 4 weapons that won the war. 80 years after that, restorers will still rebuild these engines, knowing their grandchildren might need a second overhaul. The engine that failed Roos's test became the Willys Go Devil. It is a study in what happens when a company builds for survival instead of planned obsolescence. Willys Overland was not supposed to survive to build anything. The company had hemorrhaged $35 million between 1930 and 1932. By 1936, they had sold off most of their factories just to stay solvent. The Toledo plant that would produce a Jeep every 80 seconds was, in the mid-30s, a graveyard of unpaid debts and unsold inventory. When they crawled out of bankruptcy in 1936, they had one asset, an outdated 4-cylinder derived from the 1926 Whippet passenger car, and one new hire who could do something with it. Barney Roos arrived in 1938 with a resume that read like a tour of American automotive aristocracy. General Electric, Locomobile, Pierce Arrow, Studebaker, where he spent 11 years as chief engineer. Colleagues described him as stubborn, short-fused, impatient, also an undeniable mover. He had designed straight-8 engines for luxury cars. Now he was being asked to rebuild a wheezing 4-cylinder that had been killing itself on the dyno for over a decade. Roos understood something that would become rare in automotive engineering: the capability that matters versus the specification you write on paper. A specification is what you promise on paper. A capability is what survives when everything goes wrong. The original Whippet 4 met its specifications. Adequate power for an economy car, passed standard quality checks, destroyed itself after 22 hours of sustained operation. Meeting specifications had made the engine unreliable. Exceeding them would make it unkillable. Roos did not tweak the engine. He re-engineered its DNA. He ripped out the heavy cast-iron pistons and replaced them with aluminum units weighing just 340 grams each. He swapped the old Babbitt metal bearings for precision insert bearings manufactured to tighter tolerances. He forced the crankshaft into balance, counterweighting it to eliminate the torsional vibrations that had been shaking the original blocks apart. But the critical fix was lubrication. The original engine used splash lubrication. The crankshaft dipped into an oil bath and flung lubricant around the crankcase. Fine for Sunday drives. Catastrophic under sustained load. Roos installed full-pressure lubrication. Oil pumped to every bearing surface under positive pressure. The engine no longer hoped oil would reach critical components. It guaranteed it. He revised the valve train and redesigned the cam lobe profiles. He lightened the flywheel from 57 pounds to 31 pounds. And then he did something that revealed his understanding of manufacturing. He ensured the entire redesign could run on Willys Overland's existing tooling. The company could not afford new machinery. The redesigned engine had to fit the same factory, the same line, the same fixtures. Bankruptcy constrained innovation. That constraint forced elegance. Every modification delivered maximum durability improvement with minimum production disruption. Months later, the rebuilt engine went back on the dynamometer, throttle wide open, and Roos walked away again. The engine ran for over 100 hours at 60 horsepower and 4,400 revolutions per minute. It exceeded the benchmark. They named it the Go Devil. In June 1940, the United States Army approached 135 American automakers with a request for proposals. They wanted a light reconnaissance vehicle. The specifications were demanding: quarter-ton payload, four-wheel drive, a maximum weight of 1,275 pounds, and a prototype delivered within 49 days. Most manufacturers ignored the request. The weight limit alone was considered physically impossible for a four-wheel drive vehicle. 3 companies responded. American Bantam was a tiny outfit in Butler, Pennsylvania, building British Austin cars under license. Ford had effectively unlimited resources, and Willys Overland was still clawing its way out of bankruptcy. All 3 failed to meet the weight spec. Bantam's Karl Probst called the limit impossible from the start. The Army tested all 3 prototypes at Camp Holabird, Maryland, in November 1940. What set the Willys apart was its engine. The Go Devil produced 60 horsepower. Ford's prototype made 45. Bantam's produced even less. In testing, the difference was not subtle. The Willys climbed grades the others struggled to summit. It pulled loads the others could not move. But the Willys was also heavy. Roos had ignored the Army's weight limit. He understood that a light vehicle with inadequate power was useless. A heavy vehicle that could move was a weapon. The Army, after testing, did something bureaucracies rarely do. They did not just grant a waiver. They admitted the original specification was physically incompatible with the durability they required. They raised the limit to 2,160 pounds, then kept raising it until settling on a standardized combat weight around 2,450 pounds. Roos had gambled that the Army would eventually realize they needed power more than weight savings. He was right. In July 1941, Willys won the contract for 16,000 vehicles. In November 1941, production began. But while Willys was building for the end of the world, the rest of Detroit had learned a different, more profitable lesson: how to build things that break. That lesson came later. First, the Go Devil had a war to win. By late 1941, Roos's gamble paid off. His overbuilt engine was not a prototype anymore. It was the heartbeat of an army. At peak, the Toledo plant screamed, spitting out a finished Jeep every 80 seconds. 15,000 workers coordinated in a choreography of assembly that the pre-war factory could never have imagined. By the war's end, Willys had produced 362,000 Jeeps. Ford, manufacturing under license with Willys blueprints and the Go Devil engine, contributed another 280,000. Total wartime production, 647,000 vehicles. The engine that had failed at 22 hours was now being installed in vehicles that crossed the deserts of North Africa, the frozen forests of Europe, the jungles of the Pacific. In every theater, under conditions no dynamometer could simulate, the Go Devil performed. The specifications tell only part of the story. Displacement was 134 cubic inches. Bore measured 3 1/8 inches. Stroke measured 4 3/8 inches. This undersquare configuration, where stroke exceeds bore, produced an engine optimized for torque rather than horsepower, delivering pulling power at low RPM rather than peak output at redline. Compression held to 6.5 to 1, conservative even by 1940 standards. Low compression meant the engine tolerated fuel of varying quality, from high-octane aviation gasoline to the dregs of a captured enemy supply dump. It meant reliability across conditions no specification could anticipate. The L-head configuration, with valves arranged parallel to the cylinders rather than overhead, sacrificed some breathing efficiency for mechanical straightforwardness. Fewer moving parts to fail. A soldier with basic mechanical training could service the engine in the field. The design accepted a modest penalty in power to gain an immense advantage in repairability. This was Roos's philosophy embedded in every component: not maximum performance, maximum durability, not the engine that tested best, the engine that survived longest. Eisenhower, after the war, cited 4 tools that helped win the conflict: the C-47 transport, the Jeep, the bazooka, the atomic bomb. George Marshall called the Jeep America's greatest contribution to modern warfare. War correspondent Ernie Pyle, who had seen more of the war's reality than most generals, wrote that the Jeep did everything, went everywhere, faithful as a dog, strong as a mule, agile as a goat. The engine they praised was the Go Devil. 60 horsepower and 105 pound-feet of torque, packaged in 365 pounds of cast iron that could run for 100 hours at full power without complaint. After the war, Willys pivoted to civilian production. The CJ-2A, released in 1945, was a military Jeep with a tailgate added and the blackout lights removed. The same Go Devil engine that crossed the Normandy beaches now pulled plows on American farms. Production continued through 1965. Licensed versions were manufactured in France, Japan, and Argentina. The Hurricane engine that replaced the Go Devil in the 1950s was not a replacement. It was an evolution, an F-head conversion of Roos's original design. The architecture he perfected in 1938 lived on for another 2 decades. Today, tens of thousands of Go Devil engines survive. Restoration shops report that if you start with a good block with no cracks, the engine will outlast its current owner. Your grandchildren will worry about the second rebuild. In 2024, a restored 1945 Willys MB climbed the Switzerland Trail in Colorado. It tackled rocky mountain terrain that would challenge modern Wranglers. The 80-year-old Go Devil ate the trail without complaint. The only malfunction was a sticky horn. This durability was not an accident. It was a design philosophy that has become almost incomprehensible in modern automotive engineering. In 1924, while Willys was still building Whippets, General Motors executive Alfred P. Sloan introduced a different philosophy. Annual model changes, cosmetic updates that made last year's car look dated. Engineering decisions calibrated not for maximum durability, but for maximum turnover. General Motors surpassed Ford in sales by 1931 and never looked back. The industry followed. Vehicles became products designed to be replaced, not maintained. Modern engines are not designed to run for 100 hours at full power. They are designed to survive the warranty period with acceptable reliability. After that, planned degradation ensures a return customer. Plastic components replace metal. Software locks prevent independent repair. Tolerances are held to minimums, not exceeded. The contrast with the Go Devil is stark. Roos designed an engine that exceeded its requirements by a margin so large that 80 years later, the survivors still function. Modern manufacturers design engines that meet specifications precisely, ensuring failure arrives on schedule. We did not lose the blueprints for durability. We lost the tolerance for over-engineering. The Go Devil was designed by a company on the edge of bankruptcy, using machinery they could barely afford to a standard no customer had demanded. They built it to survive 100 hours at full power because Barney Roos refused to accept anything less. The engine outlasted the company that built it, outlasted the war it won, outlasted the generation that assembled it. Parts are still manufactured today. Restorers still rebuild blocks cast during the Truman administration. Every time a Go Devil climbs another mountain trail, it asks a question modern manufacturing cannot answer. What would we build if we designed for survival instead of replacement?